Right, today we're going to go over flat recursion, which is we've already been doing it actually. It's just where it's recursion on a list that is it doesn't have any sublists within it. So this is like a flat list, A, B, C, D, and then a list with something deeper in it would have like a list within it, like 1, 2, D. Alright, now flat recursion would just go through and it would just look at the top level elements, which would just be A, then B, and then the list of 1 and 2, but it wouldn't actually look inside the list 1 and 2, it would just look at that whole thing as one whole thing. And then D. Whereas deep recursion will go down, look at A, then B, then it will look, you'll see that's a list, I'll have to go inside of that and look for elements within that. So here's some alright, so for the first example of what we're going to do, if you recall, we defined a procedure called remove first in several videos ago that just removes the first occurrence of an item within a list. But now we're going to do remove all, which removes all of the items within the list. So basically we're going to have remove all A, and then a list like us, bar, Gus, like that. And this will give us the answer, a list without any A's in it. So S, P, R, G, S. Alright, now how we're going to do this. Well, actually, I think this one's a bit easier than remove first, but technically it's a bit more complicated, I guess. Alright, so the base case, we're going to have to go through the list here, and what are we going to do? This isn't the base case so much, but what are we going to do if we find the item? So the item's A, what if we find an A there? Then we're not going to cons that onto the list, are we? No, we're just going to do the remove all on the coulter, which would be asparagus, and then so remove all on asparagus. What's that going to give us? Let me just get rid of that. Okay, on asparagus, then we're going to see that there's an S there, and we want to keep that, so we'll cons the S back onto remove all of the coulter again, like that, and then we'll just keep going down and not consing the item when we find it, and consing the ones that are not the item. And then when we get to the end of the list, all we have to do is, pop out an empty list, and we should be done. Alright, so let's just define that real quick. Remove all lambda item ls. Oops, hit my touchpad on the laptop. Alright, so there's going to be 3 cases. One is if you the last thing, if it's an empty list. So we'll use the cond null ls, just do that. Okay, equal item car of ls, and what we want to do if it equals, we go ahead and we don't cons it, we just run remove all again. Remove all item on the coulter of ls, and otherwise that means it doesn't equal, so we'll cons the item onto the remove all. Oops, item coulter ls. Alright, let's get rid of that and then run it. Alright, run. Let's try this out then. Remove all A, I'll just paste this out of my notes here. Asparagus. Oh, that has not worked. Oh, I did this again. Remember last function I did something like this. So what's the problem here? Look at this. Cons item onto remove all. Now what's item? Item is A in this case, so we're just consing A whenever we find something that's not an A. So this actually does quite the opposite of what we want. Alright, so let's put this, change that to car of ls. Alright, now we'll remove all. Move all and paste that asparagus in there again. Oops, A asparagus. Alright, well that worked great. Okay, now it's time to move on to a bit more of a complicated function. This one is called append to, and it just takes two lists. Let me move my thing down here. Okay, so this takes two lists. Append to, list 1 and list 2. We'll just say like A, B, C. List 2 would be like, oops, D, E. Okay, and that will give us this: A, B, C, D, E. Okay, so let's look at this. Append to. What if this is just empty and this one's like something else, D, E? Then what do we want to return? We just want to do D, E. D, E. So let's just make that the base case. If list 1 is null, then we'll just return list 2. And now obviously you can't just cons list 1 the whole thing into list 2, because that, what will that give you? That will give you this: A, B, C, D, E. That will give you A, B, C with as the car of list 2. So you're going to have to cons each one of these individually into this list. Alright, so let's define it. Define append to lambda ls1 ls2. If null ls2, then we want to return the empty, oh no, not the empty list, we'll return ls2. Right, alright, now we're going to have to cons each one of these into this one. So let's cons the car of ls1, and what do we want to cons that into? So let's try this. So let's say this is just a list of like A and B. That's a bit easier. Okay, so now let's say we const the car of A and B, which is A, into what? If we just did D and E, that will be A, D, E. So we got to get B in there too. So we'd have to do like cons A into the cons B of D and E. Oops, D, E. Alright, and that gives us a list. So we just have to cons each one. So this is already consing A, and then we've got to have this cons B inside of here. So what would that be? Of course, by calling append to on the CUDA of ls1, then it will just do cons B next. So we're just going to go back to recursion, append to CUDA ls1 and ls2. Alright, now let's run this and try it out. Append to A, B, C, D, E. Oh dear, something wrong happened. Oh, right, yes. So what? Let's look at this. So we're saying when ls2 is null, then we're going to return ls2. But of course ls2 here is D and E, so that's not going to work because that's never going to be null. So we're just going to keep cuttering on down this list, and that's why we got the error. We got down to the empty list here, and it tried to take the car of it, and that's impossible. So then basically, well, what's wrong here? I know, but just take a guess here. Alright, so what we've got to do is check and see if this is null, ls1, and then we'll run it again. There we go, A, B, C, D, E. Works pretty good. Alright, and next up we're going to use the append function to make a reverse function.